This is a continuation of factoring methods. In this video, I'm going to show you two examples that are a bit more challenging. So we have this expression over here, and I'm going to ask you not to expand this. I'll show you why expanding is not the greatest idea. So if you find this is too complicated, you're going to let another letter, let's say A, be this inner part of the bracket, so x plus 5. When you do that, it allows you to recognize more easily what type this is. So this is going to be, there's no common factor, so you skip that. It now looks like a binomial, and it happens to be two perfect squares and a difference. Why two perfect squares? Well, because A is definitely with a square, and this is 15 squared. So then you can proceed by factoring this, saying 15 plus A as one factor and 15 minus A as the second factor. Now, because the question never had A's, you have to replace back what your let statement said. So instead of A, put x plus 5. It is important to put the inner bracket, especially on the term where there's a negative in front, because that negative is going to affect all the signs inside this inner bracket. And so once you simplify this, you'll have 20 plus x and 10 minus x as the result. This is as factored as it could go. Now, I'm going to show you how you could technically, this question, you could do this by expanding first. The second question, the expanding first, will not help you. So one disadvantage of expanding first is that you run the risk of stopping before it's actually factored, because expanding takes a while, and so you'd be like, oh, I'm done, and move on, when you actually are not. So let's go the expanding route just to show you that you could have done this, because we have this factor with a square, so you could write it out twice. Then you can proceed to distribute these two binomials by FOIL or just distribution method, whatever you prefer. Then you have to make this negative distribute inside of this bracket. Then you have to collect all the like terms. So here you cannot stop, because the instructions are to factor, not to expand. So this still has 3 terms. We want it to be a monomial with many factors. So this right here is a monomial, because there is a multiplication between factors instead of addition. So as long as adding and subtracting is captured within factors or brackets, then you're fine. So this is not factored yet. So then what you could do is list off all the factors of 200. Here they are for you. And list off the factors of the last term, which is 1x and 1x. And we know we need to have one negative. So I'm going to place a negative up here. So we need to start off with maybe the numbers that are closer together. So 10 times 1x is 10x, and 20 times negative 1x is negative 20x. And if we add 10x with negative 20x, we do get this middle term. And so these are the factors, just like we had before. So keep in mind, this method right here has another advantage, is as you'll see in our second example, expanding would not help us in that scenario, so you kind of have to know how to do this. So here's our second example. There's nothing to common factor. We count how many terms we have. We have 4 of them, so it's grouping factoring. We're going to group these two together and these two together first to try. What's common between those two is 8x squared. These are the leftovers. There's nothing in common in the second two, but we still have to write this plus sign. So plus what? Plus 1. And then keep that the same. And these brackets are not this identical, so we can't proceed. And we can't just stop here because it's not factored, because this plus sign indicates that it's not all multiplied yet. And because we were stuck because of these brackets, we want to regroup now. So here's the question again. Let's move terms around. So maybe this last one would be second term. Grouping these two together like this. What's common between the first two is x squared. Last two, there's nothing in common, but this negative has to go over here. So we were going to pull out negative 1. So this is the result. Again, the brackets do not match. So you get stuck again, and you cannot say that this is factored because this is not all multiplied here. So again, these must be the same for this grouping to work. So why don't we try to group it instead of 2 by 2? What if we group it 3 and leave that alone? So these 3 turn out to be a perfect square trinomial. So if we were to break out 16 into 4 and 4, and positive 1 is negative 1 times negative 1, and then if you crisscross this, you'll have negative 4x squared and another negative 4x squared, which is this middle term, negative 8x squared. So the factors will be identical. Instead of writing it twice, we can put this bracket with a square. And so now this is like the previous question. And as I said before, you need to know how to deal with that type of question without expanding, because if you were to expand it, you will go back to being stuck. And so because we have two terms here, so it is a binomial, so the terms are separated by a plus or minus that are not captured with a bracket. So this is a binomial, and this is a perfect square because there's definitely visible a square. And this one could be written as an expression also with a square. What expression would it be? Well, 3 times 3 is 9, and x to the 3 times x to the 3 will be x to the 6. Why? Because 3 plus 3, we add the exponents when we multiply bases, gives us this 6. And so if you were to use just a's and b's, it's going to look like this, and that's the format for difference of squares. Then you must go back to what a and b represented using x's. So here's the result. And each one of these trinomials, the variable pattern will not match for you to actually factor with trinomial methods. However, you will still be learning eventually how to use factor theorem and long division to factor this type further.